Thank you. How's this? Okay, so yeah, this is going to be about 10 years of history of logging at Facebook, and we're going to go really fast. So very quickly, I actually started at Facebook as a production engineer in 2012, so I haven't been there for the whole time of what we're going to talk about today. I've actually been on the Scribe team for the last 3 years. Scribe is the team responsible for all of logging infrastructure at Facebook. So that's going to be our focus. Before that, I worked on the OS level configuration management and our migration onto Chef. So there's Chef fans out there, we can talk later. So good Facebook tradition, we're going to have to move fast to get through all of this. I'm going to try to give you an overview so you can see like how the system changed over 10 years, and so a couple of big iterations. So maybe more like a lot of talks are, hey, this is the new thing and this is what we did a year ago. So we're going to try to take a bigger picture, but it means we have to go fast. There are reference links at the end of the slides, so if I talk about something and don't go into detail, go check the end of the slides when they're posted, and you should be able to get more information that way. So 10 years of this, I wasn't at Facebook. So if anybody can remember back to 2007, the thing that was ruining my day in 2007, I was actually working at Ticketmaster. So we sold tickets for concerts. And so the person ruining my day was actually Miley Cyrus, of all people. So the big concert tour for 2007 was Hannah Montana. And this thing was selling out fast. It was selling out in minutes or seconds, and people were upset when they didn't get tickets. They were so upset that they thought, hey, there's no way they're really selling out these concerts in seconds. No application could possibly do that. What must be happening is they're colluding with scalpers, not actually putting these tickets on sale and doing something shady. Typical thing for people to think about Ticketmaster. It's not actually true. I can tell you I was there. And in fact, we had to go to court to prove this, and we had to have the logs to back it up, and we did. So this was me spending months pulling application logs out to prove how our application did what we said it could do, and how we tracked down scalpers trying to abuse our site, and my boss going to court to convince a judge how to interpret all of these logs. So this was pretty important to us, but your logs might contain data you use to charge your customers, personally identifiable information, various types of compliance can apply to this data. Like this stuff is not just Apache like access logs these days. Right? This is like the core of your business, and this stuff is really important. That's why we're here to talk about this. So the infrastructure that we had at that time, though, was pretty simple, and it kind of looks like this. So 2007, hopefully this is sort of representative of the industry, but we used syslog. So log to syslog ng, it forwards to some other syslog ng that is our aggregation server, has an NFS mount to some storage appliance, and then you can tail those logs, and like we were a Perl shop, so slice and dice that with Perl, and you're good, right? I think this was, pretty common for the time. So that brings us to where we're going to start our story with Facebook. So that's the industry in 2007 time. This is about the time that we're developing Scribe at Facebook, and then we'll look at a couple of iterations through new backend storage mechanisms, first HDFS and then LogDevice. So the first version of Scribe was actually a single component that was open sourced. So back around 2007, 2008, we wrote this single C++ thrift server called Scribe-D, single component that was open sourced. It's now archived. So this is the big sad face of my talk. I wish this was still open source, but it's not. There is a talk from 2009, so you can listen like from the people who originally wrote it of like all the design decisions they made. Hopefully it doesn't conflict too much with what I'm going to tell you. But if this was Ticketmaster in 2007, this is us using Scribe at the same time. Looks awfully similar. So we write to Scribe-D, forward to another Scribe-D that can write over NFS to some storage appliance. So the thing that's different here is not the implementation, it's the data model. So this is Scribe's data model. This is a slide straight from that talk in 2009. It is not fundamentally much different today. So you have a category. If you're used to Kafka, this is similar to a topic. So this represents logs from a single service. And then you have a message. Whereas like syslog imposes different fields. So like if you think of a log level or a host name or a timestamp, all these things that are required, none of that's required here. If you want those things, you can shove them in the payload of your message, but you don't have to. Nothing about our data model requires it. And this has some important implications of why this system has survived. So this is straight out of the Unix philosophy. Like, do one thing, do it well. Scribe is there to be a transport layer only. We're not going to inspect the payload of these messages. We're never going to manipulate them. Like, that's all on you if you're a consumer of this. So there is an implication here, though. We're still storing these as strings that are like lines in a file on some storage appliance. And so technically a log is a new line terminated string. It has to be. But there's nothing about the data model that requires this. And by the end of this talk, we're going to change that. Apologize. Of course, I pick up a cough right before I have to speak. So how did we iterate from there? So this is our Scribe D, so we'll leave out a couple of the pieces at the end. But we're growing. Facebook is growing rapidly, so we're adding more and more nodes that have to log to Scribe, adding more Scribe Ds at the edge. And eventually we add so many that we have to fan in those connections because we can't handle all the connections on single hosts. So you throw in a layer of fan in and then fan this back out to a Scribe D to write to multiple storage appliances. And so this is all great, but what happens when you can't get enough storage appliances? They aren't big enough. So we start looking around for something that kind of looks like a file system but is bigger. So what's happening around this time in the industry, but also at Facebook, is our data warehouse is developing solutions for this. So the big thing in this was big data. This is like the big data buzzword was hot before containers, our previous buzzword of the day. So the Hadoop ecosystem was a thing. So HDFS, the Hadoop file system, this was a big file system looking thing. And in fact, our data warehouse team was running some of the biggest HDFS clusters in the world. They were helping to originate Hive, which is a SQL-like query interface you can run on top of HDFS. And so we could go talk to these guys that are experts and we're like, hey, can we have a giant file system looking thing? And they're like, yeah, man, how big do you need? Like, we got it. So cool, let's drop that into our infrastructure. So we can do this. So Scribe D is the C++ thrift server, but we can like use JNI and teach it to talk to HDFS. But it's pretty slow crossing languages like that, and it doesn't work super well, and we've still got all this fan in. But Scribe D is just a thrift server, so it's pretty simple to re-implement the same protocol in another language. So we're like, well, we'll write a native Java version of this component, and then we can do all of our interactions with HDFS natively in Java, and this stuff will be way faster. So we wrote a component called Calligraphus. Calligraphus was this re-implementation and like solved a lot of these problems, improved our performance significantly, but didn't change the layout too much. The cool thing though is now we've got all of our log data in HDFS. So now it's pretty straightforward to do like an ETL process, shove all this data into the data warehouse. Now we can start doing data warehousey things. We're hiring data scientists, and they're like, hey man, we can show you how to do Hive queries. And like that blows grep out of the water. It's really awesome. And, like, so now we're using Hive for this stuff. And that's fine, but I'm just a lowly sysadmin, and like I just want to tail some logs. Like, how am I going to do that with HDFS? And you can't, but we could make something that works like that. And so we wrote one more component that we called ptail. So you could hand ptail a category and say, hey, I want to tail these logs. And it would go to multiple HDFS clusters, find all of your data and pull it back so that you could do kind of whatever you want. And that's great, but there's a couple problems with that. The biggest problem is HDFS has some rules. One of the rules is you need to completely write a file and close it before you start reading from it. This makes it very difficult to implement something that looks like tail, something that looks like streaming. The solution to this turns out to be very simple. Just do it anyway. In true Facebook tradition, we climb inside the Hadoop client and we're like, we're going to read under construction files and like whatever, we'll deal. And so sometimes those files will get hung, and we ended up having an external process that would hunt around for hung files and force them closed, try to put this thing back together, but it was actually surprisingly stable. In fact, it was so stable that our entire stream processing ecosystem is built on top of ptail. This is a lot more than just grep. So there is a paper called Real-Time Data Processing at Facebook that describes our stream processing ecosystem in detail, but it's a lot of these components. I'll just highlight a couple of them. So Scuba is our like real-time analytics, like troubleshooting. So you can take any kind of data you want and shove it into Scuba and slice and dice it however you want, kind of ad hoc queries. It's awesome. It's one of my favorite tools at Facebook. Deserves its own talk, really. The other ones are all frameworks that you can build stream processors on top of. So for example, if you ever hear us talk about daily active users on the site, so how we measure how many people used Facebook.com yesterday, this was once a batch query that you do. At the end of the day, you do do a Hive query that would take hours and hours to count how many people used the site yesterday. Well, now that's a streaming query in Puma, and so it's updated all the time. It's much more efficient and much more real time. So this stuff is super powerful. So now, this is one of the reasons why Scribe sort of ceased to be open source, is because now we've got this ecosystem of all these different components. It's a lot more to maintain and a lot more tied into our infrastructure than just one binary. So unfortunately, still sad face, but that's kind of why. But this isn't what customers see, right? You guys have looked at other logging infrastructures, and so it's this big thing where all the arrows all point into one thing and then point back out, and that's what you want a service to look like for your customers. So for us, this is all the other teams at Facebook. So that kind of looks like this. They know about Scribe because they write to it, and they know about ptail and how they get data back out, but the rest is just this fuzzy Scribe service thing. And that is as it should be, but you guys want to see how the sausage is made. So this is actually more complicated, right? This is actually multiple redundant backend clusters that run that calligraphous and HDFS stack, and a bunch of ancillary stuff we won't get into, like how do I register categories, how do I blacklist bad actors, a bunch of other stuff. And it's in fact more complicated than that because we run in multiple regions, and so it looks more like this. We don't want a failure of the backend to mean that Scribe can't write, so Scribe has to be able to write cross-region, and if your data ends up in another region, ptail still better be able to go get it, so it has to connect cross-region. Oh, and by the way, this is Facebook, so our regions are actually more like this. Excuse me. So you can see how we can hit some limitations, but this actually got us a really long way. So we're scaling up the number of writes. If you watched that video from 2009, this is, I think they said, hey, we're planning this thing for maybe hundreds of categories. Well, by this time we had thousands of categories, and we're writing hundreds of gigabytes a second, and this is growing fast. The growth rate is really scary. We need to figure out not just how to scale this thing up, but how to scale it up by an order of magnitude. And it turns out that we could keep adding backend clusters and it would scale our ability to handle more writes, but it didn't scale our ability to handle more categories. That category metadata was the real limiting factor because, like I said, every client has to be able to potentially write to any backend cluster, so every backend cluster has to have all the metadata for every category that exists, whether it needs it or not. And this became a real scaling limitation. So we did come up with a way to kick that can down the road a little bit. It was a little heavy-handed, but we had this concept called scopes. Now a scope lets us split categories and assign them to one scope or another and assign backend clusters to one scope or another. And that way a backend cluster only has to have metadata for the categories in its scope. So we can kind of cut that problem in half. The problem with this, or a big problem with this, is it cuts our excess capacity in half too. So sometimes if things would go wrong, we'd have failures or there'd be some flood of writes. Our writes would go way up, and if you have excess capacity, you can just handle it. And we're taking our buffer capacity and cutting it in half for any given scope. So it's really unfortunate in terms of handling failure. Oh, and by the way, you saw that we have this entire streaming ecosystem, and although it does run on top of the hack that is ptail, it's still built on top of a hack, and it would be nice if this was a first-class citizen. And finally, HDFS sadly had forked from community HDFS, and basically the data warehouse team was moving away from it entirely, and not only did they not really want to support it anymore, they certainly didn't want to support it for us, this weird use case that wasn't really the data warehouse. So we needed something where we could get support. And this is where LogDevice comes in. So LogDevice was actually originally written before we looked at it back in 2013 or so. It was finally open sourced in 2018. So this is out there now. You can go check it out. Whereas HDFS was a distributed file system, and we just happened to use it to store logs. LogDevice is from the beginning a log store. This is its primary use case. And in fact, it was built around a very academic idea, an explicit definition of what a log is, and not the implicit one we inherited from our storage. So that definition is a record-oriented, append-only trimmable stream. This is maybe familiar to some of you. There's a great article, Jay Krebs, who was at LinkedIn at the time, now at Confluent, originated Kafka, wrote this article that I'll link to at the end that talks about the academic basis of how you should think about what a log is and why it's this first-level data structure. And as we said, this is no problem for Scribe. There's nothing in our data model that is incompatible with this. So like we can totally think about using LogDevice. It's a little bit more about what LogDevice does. Like I said, streaming is first class. This is their primary use case. It has a bunch of features that we had to add on as the ancillary components on top of HDFS. So trimming of old data, transport encryption, all these things are built in from the beginning. And also there was a dev team dedicated to this. They were super excited to have us as a use case, wanted to support us, and had a plan to open source. And also, if you've used HDFS, you have to manage name nodes. So if you have a big cluster, you have to be careful about how you do maintenance to make sure that you don't have name node problems. Well, all the metadata in a LogDevice cluster is completely distributed. There's no name nodes, no nodes are special, and it makes maintenance a lot more pleasant. So that was the big project. This is about the time I'm joining the team, and we're like, hey, we have this great 6-month project for you to manage. Of like, we're going to swap out this storage engine. It'll be great. It was a little more complicated than that. So this is our ecosystem, right? With HDFS in the middle. And all we want to do is drop LogDevice right on top of that. But this is right in the middle, so we're changing a lot. This is not a greenfield project. There's a lot of constraints here. But one of my favorite things is actually looking at constraints and turning those into, make that problem space smaller. I'm not that smart, and so just coming up with out of thin air how to do a thing is not actually my favorite thing to do, but figuring out how to cheat on a problem by being clear about exactly what problem has to be solved and what part doesn't is much more up my alley. So let's look at what some of those constraints are. So we wrote this Calligraphist component, right? This is the right side of our migration. Calligraphist was written specifically to talk to HDFS, so it had to go. We needed something else to fill this role, and so we were going to write a component called the Scribe X router. The X is for 10x, that we wanted 10x scale out of this, right? Silly name. So we needed a component to do that. We had a couple more constraints. This had to be a thrift server, and actually all of Facebook's sort of routing and service discovery is built around thrift services on the back end, so there's a lot of tooling we could use here. And we also had that scope concept. And this turned out to be super important because scopes let us divide up back-end clusters and isolate them from each other. And this is perfect because that way we can make the LogDevice clusters completely isolated in a separate scope from the HDFS-backed clusters and migrate between them. And so instead of cutting over the system, we could cut over categories individually from one to the other just by migrating scopes, migrating a category from one scope to another. And in fact, we could double write. We could write one category to both backends and then compare what comes out the other side and make sure it's the same and prove that this was stable. And that was going to be really important because we're replacing this mature system. There's a caveat here, though. So for most use cases like a web server, the log volume on a single host is very low. So if we wanted to double that output just so we could do double writes, it's no problem. They're not going to notice. But for a few applications, they're actually pushing the performance limits of a single Scribe instance. So if we doubled their write output without telling them, we were just going to drag them down and hurt their throughput. So that wasn't possible. And so really we just had to punt on this. For certain categories, we had to identify them and say, hey, we can't do double writes for you. We'll migrate you at the end when we're very confident that everything's going to be fine. And that'll just have to be what you do. So we've got a strategy for that. Next is the Hive loader. So we've got this Hive loader, again, written purpose-built to work with HDFS. And it had become this special case because the whole rest of the ecosystem is hanging off of PTail. So it would be great to simplify here. So we're going to have to rewrite it, but we were going to rewrite it to work in a way that it used the tailor instead of LogDevice directly. Take this opportunity to reduce complexity. But that makes it even more important that we change PTail. So we had to have something that we could get rid of all these hacks that we did in PTail, but we needed to be able to read from LogDevice. So we needed a replacement, but that replacement couldn't change the fundamental downstream interface of PTail, which I haven't actually told you what that is yet, but we're going to write this thing called ztail, because xtail sounds kind of funny, and it's going to drop in and replace PTail. So the interface kind of looks like this. PTail is not a library. It's not something you include in your app. It's kind of hard to do that cross languages. And so if you write your little streaming app, you build your app, and then when you deploy it, typically into a container, you declare PTail as your package dependency and specify some version, and then start it up by starting PTail and just piping the output into standard in of your app, standard Unix pipes, dead simple. The number of times I've had a developer tell me, try to blame their streaming problems on Unix pipes, I think out of all of those, maybe once it had anything to do with pipes at all. Pipes are pretty solid. So anyway, the big problem with this though is nobody ever upgrades, and they don't upgrade because this isn't a build time dependency. They would just declare some version of ptail in their config for their container and then just never change it. And we'd be chasing them around forever trying to push new versions. So that wasn't going to work for a big migration. We're going to be building new versions, pushing them, trying to iterate on this thing, and we have to be able to do this stuff a lot. We can't be waiting on everyone all the time. And we had to be able to swap in Ztail at the right moment so that we didn't interrupt their stream. So the solution to this, like for both of these things, was the same. We did one upgrade that people had to make a change to get on a new version of ptail, but it wasn't really ptail. The binary was still called ptail, but it was this thing we call the ptail auto upgrader. It was a little wrapper that when you started it up would act like ptail, but it would go download ptail, like a version that we specified via config, and then start it up as a child and then redirect its output into its pipe. And so it would look like ptail for your downstream app, but really we could control it. And in fact, we could get the auto upgrader to, on the fly, swap in a new version of ptail that it would download, like while the app was running, and switch it out so that like you just saw this little blip where you like didn't have anything in the pipe for a second, and you would continue on with life. And now we could force upgrades on people without having to talk to them, like every sysadmin stream. And what's more, it was aware of scopes. And so if we changed the scope of a category, it could tell that, hey, I need to be running Ztail, not ptail. Let me go grab the right tailor and drop that in instead. So use the same process to handle the migration when you switch on to Ztail. So we had a solution there. So that's kind of our plan for this supposed 6-month project. But we have to productionize this thing. We actually have to get this thing into prod. So I have a little graph to show you. Unfortunately, this graph doesn't have any axes, which is probably not that surprising to you. I'm sorry about that. But you can get a sense of how this worked over time. So on the far left, the red graph there, or the red line there, is when we had the initial implementation of that ScribeX router component. And then let's also put a line for what the write rate into the whole system was at that time, so we can keep track of it for later. So you can already see that there's this steady growth rate that's continuing as we try to get this thing rolled out. Well, we pretty quickly had a Ztail prototype ready to go as well. We could start iterating on these components. But it ended up taking us all the way till here to be ready for a real production scale test. This was a mature system, and so we figured, hey, well, first of all, for one more second there, you can see that this is like probably almost doubled our writes just in the time that we're getting ready to do a production scale test. So yeah, that's the goalpost moving on us. But this is a mature system, so we couldn't just sort of like try this and see what happened. We had to be sure, and so we're like, well, we know HDFS really well by now. We can give the LogDevice team a really clear spec of exactly what we expect, and we're totally not going to forget anything. Yeah, no. That's not the way it works. When you have a system you know really well, you're going to take stuff for granted, and you're just not going to recognize some of the important parts that you wouldn't even think to tell people. And that's what happened to us. The only advice I can give you here is what we should have done and didn't do is just put the LogDevice team as on-call for HDFS from the beginning. Make them support it. And that way they would really know what's good and bad about the thing that they were replacing. This is really the biggest thing I would change if I did this project again. But we did get through this time, and we got something that we could test in prod doing those double writes like I talked about. So let's slide this graph forward a bit. So now you can see that by the end of our production testing that was supposed to take a month, really took 6 months, we had tested with half of the write throughput that we originally had in production when we started this project. But the actual target for real production had moved on significantly as we continue to do. So why did this take so long? So there's a lot of reasons, but one big one is we were double writing, right? We're writing to both and then comparing the output. This is a great thing to be able to do. We would see some discrepancy. We were missing some lines on the LogDevice side, and we can go hunt for a bug, like where are we dropping some data, go find the bug and fix it and see it work. It's perfect, right? But we had one instance where we lost a couple of weeks because we actually were getting more data in LogDevice than we did in the HDFS-backed tailors. We couldn't figure out why. And we looked and looked and looked for where we were introducing duplication in the system. And the reason it took us so long to find it is that we weren't. LogDevice was completely correct. It was HDFS that was wrong. We had assumed that it was fine, but we had latent defects in the system because we'd never had anything to compare it to before. And so we needed to compare, you need to question both systems, especially if you've never had a basis for comparison before. We were looking in the wrong place. Also during this time, we had to test the actual path of migration. So like I said, we're going to replace ptail with ztail under the hood, and it has to be transparent. It needs to work the same way. Well, ptail does have some command line options that you can specify that change the semantics of how it works in subtle ways. I wish I could tell you we had perfect testing for every possible permutation of every option you could specify, but of course we didn't. And we could have gone back and spent a lot more time adding that, or we could cheat. And that's what I always recommend, especially when you can cheat with empirical data from prod. And that's exactly what we did. So we instrumented the ptail auto updater to log every command invocation of ptail in all of prod and shove it all into Scuba. And so we could use Scuba to slice and dice all of that data and figure out exactly what the big use cases were and start grouping together all of our different tailors and grouping together all of our use cases. And so this makes the data a lot more manageable. It makes it so that we can tell how we can structure our migration path, like which categories are we going to migrate together. So a big thing here is like if I'm going to migrate 10 categories at the same time, if I migrate 10 categories that are all tailed in the same way, they're all the same use case, if something goes wrong, it's probably going to be the same thing for all of them. But if I pick 10 categories at random, I might have 10 different problems that manifest in different ways, and now I'm just like, we're going to hit all these problems eventually, but they're all going to hit at once, and the team's going to be really stressed chasing all different things. It makes it a lot easier to manage those weird edge cases you're not going to catch by picking when you're going to hit those problems and how many are going to come at the same time. So you can use that data, and we're using all these tools that we support to actually run this thing. So we were able to get through testing, start the migration. So from that last red line there, this is us doing actual real production migrations onto the new system. And by the time we had the same number of writes in LogDevice that we had at the beginning of this project, we were 15% of the way. So we're moving, but not quite fast enough. So there's two more things that we need to get through this. One is we need a solution to the Hive loader, because that was just about finished. It took longer than some of the others. And that would let us move a lot more categories. And we needed to be able to get through the migration faster. So we needed better automation. So let's talk about the migration automation a little bit. One thing that's really awesome about our environment, and that I recommend to you, is it needs to be really easy to write tooling. So for us, a lot of our internal tools are all built on the same frameworks. They're all Thrift services. They all have Thrift interfaces, and they're all based on the same configuration system. And the thing that's really great about this is not only does it make it really easy to write small little tools like what we needed to manage the migration, like a little Python CLI that would help us batch up these categories and run the migration. It makes it easy enough to make them that it makes it okay to throw them away. The harder this stuff is, then the more you're going to like fall in love with it and not want to throw it away when you're done. You want this stuff to be simple. You want to be able to throw it away. Like write that temporary thing and put it out there and then throw it away when you're done. So we did write a little CLI, Python, and it interacted with a bunch of different Facebook systems. So this was how we told category owners that they were going to, like when their category was going to migrate, do capacity checks to see whether or not we had enough LogDevice capacity to handle the categories we were going to migrate that day, actually do the migration and do the checks when we were done, all of this stuff. And like I said, we could integrate with other systems pretty easily. So just as an example, there's a thing about how our configuration system works. It's called Configurator. It gets fairly complicated, but the interface is really simple, and you can do Python and Thrift type things to generate static JSON files and effectively represent the config as static JSON. And so this is really great because like this is how we batch together the categories. We had a really simple data structure like this that's just here's a date when we're going to migrate some categories and an array of category names to migrate. These are fake, of course. But by doing that, then we could build things like customer dashboards. And so we could hand them a dashboard and say, hey, you can watch this. But since we don't have our migration like batches and the names of categories in a spreadsheet or some like manual thing, if we want to make a change, I go do a diff to move that from one batch to another. Everybody can see this change. We have a really clear record of it. And every like piece of automation or piece of monitoring that's been built on top of those concepts of batches just updates dynamically. And like this is a super important quality that saved us a ton of time. It prevented mistakes. So having the environment set up in this way like allows us to do things that prevent mistakes, which is super valuable. And that did in fact work. We were able to move on and really start making progress since we quickly ramped up to being 50% of the way there. And then eventually we got to a point where we were almost completely done, but we were hitting close to the holidays, and so we weren't going to ruin anyone's Christmas. So we took a little pause, and finally after the holidays, migrated everything. And everything was fine until the day after we migrated the last categories. And I got this frantic task from some people that were like, hey, we have this tailor and it migrated yesterday and today we got no data and you're losing all our data. What are you doing? They work for the ads team. They get a little stressed. So we go look at this. I'm like, okay, tell me what this tailor does. What are we doing here? And so what this tailor actually did was they had another job separate from this one that ran at the end of the day, and they tried to gather stats for the previous day. But if you remember that in HDFS, we were rolling over files, it turns out every half an hour, to store data for a single category. And since we couldn't guarantee that that file would roll over at exactly the right moment, sometimes you would get a little bit of data that ends up on a file for the following day, where the log line actually belonged. And so they had a little tailor that would look at the last couple hours of the day or the first couple hours of the early morning and put those lines back where they actually belonged in their downstream system. And so when they switched over to LogDevice, they stopped getting any output. And they're like, well, there's nothing in the wrong place. And there's always something. And the problem was actually that LogDevice cuts off the way it's supposed to. Everything is event-oriented, log-oriented, and not these files that we have to roll over at some arbitrary point in time. So this job is completely unnecessary. The problem was with the old system. So this turned out really great. Aside from a minor heart attack, we're just like, delete that job, you don't need it anymore. Like, we got you covered. So that is actually the end of the migration. But I kind of promised you guys some magic. I should leave the graph because graphs are more fun. So the whole beginning of this was, hey, we're going to build this thing out of a really simple component. We're going to be really agnostic with our data model here to what people are doing at higher levels. We want you to layer complexity on top of this and not have to change Scribe. So what can you actually do with that? Let's look at some use cases for Scribe at these different layers. So the lowest layer is raw Scribe. So testing is a great example of this. There's a little utility called Scribe cat that's just a little binary that you can like shove some data at it and it'll write it into a category for you. And it's great for testing. But it turns out we actually have production use cases that need this. They can't depend on anything. They can't depend on thrift. They can't be compiled with any of that. And one of these is how we use Chef. So Chef is how we set up like the base level OS components. And so it sets up like the dependencies that we have. It even sets up the Scribe binary, like the Scribe daemon that runs on her hosts. So we need to avoid all of these dependencies. And I'm willing to sacrifice any kind of structure in order to get it. But I want to be able to get run stats from my Chef runs into Scuba so I can slice and dice them just like everybody else gets to. And so we can actually use ScribeCat to do exactly that. So if you ever looked at Chef handler codes, just Ruby, and so it looks kind of like this. We can generate our stats, and I can pretty well trust that Ruby can generate some JSON that's vaguely valid. It may not be valid for Scuba, but it'll be JSON. And we shell out to ScribeCat and hand it some stats. And this is a super low dependency way that we can get stats out of Chef and get them back into our pipeline and write them into Scribe and pull them out into Scuba. So we don't have any validation, but I'm willing to sacrifice that. So what about syslog? We started all this with syslog, and syslog imposes the schema on us that we have to deal with, and that doesn't fit Scribe at all. We actually use our syslog now, not syslog-ng like in the Ticketmaster days, but our syslog has this omprog module where you can hand it a binary that you can route data to. And so we wrote a custom binary called omscribe just for our syslog to use, but all it really did was shove that data into Scribe, but it knew how to handle the schema coming out of syslog and put that into a format and just shove it into the payload of the message in Scribe. And that's great, but now we've got all this stuff coming from syslog with all this schema, but Scribe doesn't know anything about it, and it's like, how are we going to handle this? Well, Scribe continues to not care, and we handle this by using the tools that we have downstream. So we have Puma and Stylus, these things where we can write like arbitrary slicers to slice up and do transformations of our data. So we just let Scribe handle it, and then we read it back out and do stream processing on it, and that's where we actually handle that syslog schema and convert it to whatever we need it to. Convert it to something you can write into Scuba, convert it into something you can shove into Hive, whatever you want to do. And typically what happens is that stylus job or whatever is going to write back out to a different Scribe category that'll get read into some other pipeline. So you end up with these big chains of pipelines, which again Scribe is completely agnostic to. But that's a bunch of infrastructure stuff, so stuff I care about. But most of our developers are writing Facebook applications, they're writing custom code, and so we have a Scribe client library, of course, that they can like compile directly into their application and do all this stuff themselves. So once you're doing that, you get fully custom integration. You can use the Scribe client, give it data in any way you want, but this means you have to manage all that schema. You have to know what destinations you're planning to send this to, whether it's Hive or Scuba or whatever it may be, and handle that. And if you ever want to make a change, you're probably going to have to change your schema and redeploy your app as well. And especially if, like, say some backend team comes up with some like optimization that could apply to a lot of different people, this means massive code mods or going and chasing around thousands of developers and begging them to do this thing, because like they've got product concerns on their mind. They're mostly not thinking about logging efficiency. So it would be nice to have more structure here. And we can layer that on, still not changing Scribe. So we have a thing that's called simply Logger. I know there's a lot of things called Logger, but ours is special. So Logger is a library that wraps up the Scribe client, and it consumes schema that's distributed by our configuration system, configurator. So we have access to this everywhere. So not only can it take your arbitrary sort of data structure and convert it, it knows what destination you've configured, and can convert it to an appropriate schema to send it to that destination and then send it to Scribe for you. But also, because this is all controlled by configuration, you can push config changes that'll add new destinations and potentially not have to change your application. And you get automatic validation of all this stuff, and so this stuff is really great. So it kind of looks like this. So maybe you want to log data to Scuba, like I've been talking about. So you write your app to use Logger, you've handed it like a hash or whatever, and it converts that to JSON for you, sends it to Scribe client. Scribe is unaware of all of this and just passes it to Scuba, and Scuba deals. And that's really cool, except for like Scuba JSON's pretty inefficient, right? Like we're doing over-the-wire compression, and that's fine, but serializing into JSON takes a lot of CPU. Deserializing it takes more CPU. It doesn't compress super well, or rather it compresses well, but there's a lot of extra data we could cut out of there versus like some packed binary format, something like that. So we could save all kinds of resources here if we could do this, but again, I don't want to go talk to thousands of developers. But what if we could do like frozen thrift objects? Like that's pretty common because like we use thrift for lots of things. So if you think back, like finally we're on something where that new line terminated string that was like implicit in our storage, like we don't have that anymore because this is backed by LogDevice. So if we want that log message to be a binary blob, that's totally fine. We can just sub that in there and Scribe doesn't care at all. And so that's exactly what you can do. So make that change in Logger and Scuba. Scribe is totally unaware of this, and so for specific categories based on configuration, Logger was able to swap in thrift instead of JSON without the applications having to change anything, and suddenly hundreds of apps are now using this more efficient format, saving network, saving storage, saving CPU in a lot of different tiers that are handling this. And the only way I noticed this in Scribe, besides them like they were nice enough to tell us, was looking at the graphs, and all of a sudden we're using way less resources across the board. But otherwise we were completely agnostic to this. And that's the magic of like having these isolations, is not just being able to do something cool like that, but being able to do that in a way that one team can manage it and everybody else can benefit without having to get involved. So that is the last thing that I have for you. I put together this like conclusion, but actually I'd rather just get to some questions and things like that. So let me say thank you to you guys for listening to me. I also want to say thank you to the Scribe and LogDevice teams. Lots of people have worked on this over the years. So I threw together a few pictures. So thank you to all of these folks as well. If you guys do have a couple questions, I'll take some, but I'll also be hanging around. And remember, there's these reference links at the end. Go download the slides for that. There's one.
Hey, Jaron from Robinhood. So from a logging perspective, how do you kind of deal with the problem of like a bad application owner writing a verbose logs that kind of like 1x's or 2x's your storage and your, I guess, in your queuing system?
So this can be a huge problem. In the earlier days, this was a really big problem. It's one of the reasons why when I talked about cutting into our buffer capacity, that was so dangerous, is because we use that buffer capacity to some extent allow for a little bit of those spikes. But I sort of briefly mentioned there are some ancillary components in the system. One of them is blacklisting. So categories are registered with a rate limit, and if they go over that rate limit, they basically get a choice. Either when they pass their rate limit, they get blacklisted and we just start dropping all their data the moment it's logged, or they can choose sampling. And so then if we say, they declare they're going to write at 1 gigabyte per second, when they pass that, then we start dropping any data above that, and they'll still get their 1 gigabyte a second, and everything else will be dropped.
Is that at a file level or a service level?
It's defined at a service level, but it's implemented at Scribe D at the edge. And so that data never even hits the wire.
Gotcha. And are these the queuing system that you use? I can't remember if it's Scribe or Scuba, but do you send these like the topic-like configuration? Are these topics at a service level?
They can really be whatever you want. You can register different categories, so typically they're for a specific service, but some service may have multiple categories for different purposes.
So that means that a application could potentially produce the multiple topics?
Yes. Yeah, we usually group the categories that are registered by the on-call that people tell us is responsible, and so we're like, however many categories you register, like we're going to give you an entitlement for your whole team, and you can break it up however you want.
Thank you.
Hi, thanks for all the awesome content. Question about retention. Were there points throughout the sort of evolution of this service where you reduced retention periods or had to address any of that?
So in Scribe, right now you can choose your retention when you register your category, but you can only have up to 7 days of retention. For the most part, hard drives have been getting bigger, and so we've been able to maintain that. There have been a couple cases where people wanted longer retention, and for the most part they didn't get it. So Scribe's not intended to be for long-term storage. So we'd say if you wanted long-term storage, write it and then tail it back out and use that to write it into your permanent storage if you need that.
Awesome. So that solves your GDPR problems as well.
Yep.
Neat.
All right. Thank you guys so much.